Hello everybody, welcome to my channel Sujit's ChemBioTek. Today my topic is previous year question solve of NEET exam based on molecular orbital theory. My first question is, which of the diatomic molecular species has only pi bonds according to MOT? Following options are N2, C2, Be2 and O2. To solve this question, at first we write the electronic configuration of 4 species. N2 molecule contains 14 electrons and its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2p x2, pi 2p y2, sigma 2p z2. It contains sigma bond and pi bond. In C2, total electrons 12. Its configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2p x2 and pi 2p y2. Here, the valence 4 electron present in 2 pi molecular orbital. These are pi 2px and pi 2py. So C2 consists pi bonds only according to MOT. So correct option is C2. In Be2, total presence of 8 electron, it contains sigma bonds only. And O2, which contains 16 electron, its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1, pi star 2p1. So it contains sigma bond, pi and pi star bond. So correct option is B, which contains only pi bonds in its valence shell according to MOT. My next question is, which of the following is paramagnetic? N2, H2, Li2 and O2. To solve this question, we know if the valence electron in a molecule is paired, then it shows diamagnetic property. But if the valence electron in a molecule is unpaired, then it shows paramagnetic property. To solve this problem, to write the electronic configuration of the following molecules are right here. In N2, total 14 electrons are present, so its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2p y2, pi 2p x2, sigma 2p z2. All the electrons are paired, so it is diamagnetic. So N2 is diamagnetic. In case of H2, 2 electrons are present, so its electronic configuration is sigma 1s2. It is also paired in, so it is diamagnetic. In case of lithium, total 6 electrons are present. Its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2. All electrons are paired, so lithium also diamagnetic. In case of O2, it contains 16 electrons. Its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2p x2, pi 2p y2, pi star 2p x1 and pi star 2p y1. It contains unpaired electron. Due to presence of unpaired electron, it shows paramagnetism. So O2 can show paramagnetic character, so option 4 is right one. Now the third question is, consider the following species as Cn plus, Cn minus, NO and Cn. Which one of these will have highest bond order? We know bond order is equal to electrons present in BMO minus electron present in ABMO by 2. To solve this question, here we write the electronic configuration of each species and then counting the bond order of each species. Now let us first the Cn plus. In Cn plus total electron is 12. So its electronic configuration is sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 pi 2px2 and pi 2py2. These four underlined MO are BMO which contain 8 electrons, and this sigma star 1s and sigma star 2s are ABMO which contains 4 electrons, so its bond order is 2. In second case cyanide total electron is 14. Its electronic configuration is sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 pi 2px2 pi 2py2 sigma 2pz2. Now sigma 1s sigma 2s pi 2px pi 2py sigma 2pz, these are 5 BMO which contains 10 electrons, and sigma star 1s and sigma star 2s are ABMO which contain 4 electrons, so its bond order is 3. In NO total electron is 15. Its electron configuration is sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 pi 2px2 pi 2py2 sigma 2pz2 pi star 2px1. Now it contains 1, 2, 3, 4, 5 BMO, and its 5 BMO 10 electrons are present, and sigma star 1s sigma star 2s pi star 2ps contain 5 antibonding contain 5 electrons present in antibonding MO, so its bond order is 2.5. In case of cyanide, CNs, total electrons present is 13, so its electronic configuration is sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 pi 2px2 pi 2py2 sigma 2pz1. So it contains 1, 2, 3, 4, 5 BMO, and this 5 BMO contain 9 electrons, and 2 ABMO, this 2 BMO contains 4 electrons, so its bond order again 2.5. So the above 4 species bond order highest is shown 3 in case of Cn minus, so Cn is the correct option having the highest bond order. My next question is, which of the following pairs of species have the same bond order? Option A CONO, option B NO plus O2, option C Cn minus CO, option D N2N O2 minus. In case of CO, total electron presence are 14, its bond order is 3, and in case of NO, total 15 electrons are present and its bond order is 2.5. So CO and NO have different bond order, so option A is not a correct one. In case of NO plus, total electron is 14 and its bond order is 3. In case of O2, total electron is 16 and its electronic configuration is sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 sigma 2pz2 sigma 2pz2 pi 2py2 pi 2px2 pi star 2px2 pi star 2py2. Here bond order is 2. So in case of NO plus and O2 have different bond order, so option B is not correct one. In case of Cn minus and CO, both contain 14 electrons and both having bond order 3. So equal number of bond orders shown by cyanide and CO. Question is, which of the following options represent the correct bond order? These are the 4 options involving O2, O2 plus and O2 minus. To solve this question, we have to determine the bond order of 3 species, O2, O2 plus and O2 minus. In case of O2, which contains 16 electrons having electronic configuration sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1, pi star 2py1. It contains sigma 1s, sigma 2s, sigma 2pz, pi 2px, pi 2py, 5 BMO and contains 10 electrons present in BMO. And sigma star 1s, sigma star 2s, pi star 2px, pi star 2py. These 4 ABMO contain 6 electrons, so its bond order is 2. In case of O2 plus, which contains 15 electrons, 1 electron removes from ABMO and its electronic configuration is sigma 1s to sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2. This underlying 5 BMO contain 10 electrons and sigma star 1s, sigma star 2s, pi star 2px. These 3 ABMO contain 5 electrons and its bond order value is 2.5. In case of O2 minus, it contains 17 electrons. Its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px2, pi star 2py2. Its contain 10 bonding molecular electron and 7 electron present in antibonding MO, so its bond order is 1.5. So highest bond order shown in O2 plus, and then bond order shown O2 is 2, and then least bond order is O2 minus. O2 minus bond order 1.5, O2 bond order 2, O2 plus bond order 2.5. This is the correct order, and this order indicates the option B is the correct one. My next question is, which of the following is paramagnetic? Option A CO, option B O2 minus, option C Cn minus, option D NO. Now, to explain this question, we have to read in the first electronic configuration of these following molecules and ions. In case of CO, its contain 14 electrons and its electron configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2. All MOs contain even number of electrons, so it is diamagnetic. In case of O2, total 17 electrons are present and its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px2, pi star 2py1. This outermost MO contain odd electron, so it shows paramagnetic character. So O2 minus shows paramagnetic character. In case of cyanide, 14 electrons are present. All electrons present in MO are paired, so it is diamagnetic. In case of NO plus, all electrons are paired in defined MO, so it is diamagnetic. So option B is the right one. Here O2 minus is paramagnetic in nature. My next question is, bond order value 1.5 is shown by O2 plus, O2 minus, O2 2 minus and O2. To solve this problem, at first you can write the MO of the following species and then calculate the bond order. In case of O2 plus, which contains 15 electrons and its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1. It contains 10 BMO electron and it contains 5 ABMO electron, so its bond order is 2.5. In case of O2 minus, its electronic configuration electron present 17. Its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px2, pi star 2py1. It also contains 10 electrons in BMO and its contain 2 to 4 to 6 and 7 electrons in ABMO. So its bond order is 1.5. So option B is the correct option, having bond order value is 1.5. In case of O2, its bond order value is 10 minus 8 by 2 is equal to 1. Its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px2, pi star 2py2. It contains 5 BMO and 10 electrons in BMO, and its contains 4 ABMO, and this 4 ABMO contain 8 electrons, so its bond order is 1. In case of O2, its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1, pi star 2py1. It contains 10 electrons present in BMO and 6 electrons present in ABMO, so its bond order is 2. So actual answer here is O2 minus, which have bond order value 1.5. In this video, the last question is the pair of species with the same bond order. These are 4 options. To calculate the bond order of this species, at first write the molecular orbital diagram, molecular orbital, then electronic configuration, then we can calculate the bond order of the following species. In case of O2 minus, O2 2 minus, total electrons is 18, and its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px2, pi star 2py2. It contains 1, 2, 3, 4, 5 BMO and 10 BMO's electron, and its contain sigma star 1s, sigma star 2s, pi star 2px, pi star 2py, 4 ABMO. These 4 ABMO contain 8 electrons, so its bond order is 1. In case of B2, total 10 electrons are present, and its electron configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px1, pi 2py1. Its the 4 BMO contains 6 electrons and 2 ABMO contains 4 electrons, so its bond order value is also 1. So between O2 2 minus and B2 have same bond order, so option A is the correct one. In case of O2 plus having 15 electrons, which electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1. It contain 1, 2, 3, 4, 5 BMO, that means 10 BMO's electrons, and sigma star 1s, sigma star 2s, pi star 2px, 3 ABMO. 3 ABMO contains 5 electrons, so its bond order is 2.5. In case of NO plus, which contains 14 electrons, and its electronic configuration is sigma 1s, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2. This 5 BMO contains 10 electrons and 2 ABMO contains 4 electrons, so its bond order is 3. So option B is not correct one. In case of C, in case of NO, where contain 15 electron, its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1. It contains 1, 2, 3, 4, 5 BMO. This 5 BMO contains 10 electrons, and it contains sigma star 1s, sigma star 2s, pi star 2px, 3 ABMO. This 3 ABMO contains 5 electrons, so its bond order is 2.5. In case of CO, it contains 14 electrons. Its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2p z2, pi 2p x2, pi 2p y2. This contains 5 BMO. This 5 BMO contains 10 electrons, and this CO contains 2 ABMO. These are sigma star 1s and sigma star 2s. This contains 4 electrons, so its bond order value is 3. Bond order of NO and CO are different, so these are not the same right answer in this question. Now in case of option D, in case of O2, its content bond, its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2. This and pi star 2p x1, pi star 2p y1. Its bond order is 10 minus 6 by 2 is equal to 2. In case of N2, it contains 14 electrons and its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2, sigma 2pz2, and its bond order is 3. So bond order of O2 and N2 are different. In option 1, here bond order of O2 2 minus and B2 are same, both are 1. So option A is the correct one. This is my video. Thanks all of you to watch my video in this channel. If you like this type of video, then please subscribe my channel Sujit's ChemBioTek and press the bell icon and like, comments and share this video. Again, thanks all of you to watch this video in this topic. Thank you.